With that, I'd like to thank the two presenters for coming, and I'm going to turn it over to Tanner to start his presentation.
All right, thank you, Renee.
Thank you.
Let me see if I can get my screen opened up. All right, are you seeing the presentation?
Yes, we are. Thank you.
Wonderful. All right, so thanks again for having me and for reading the bio. Like Renee said, I'm the Eastern Panhandle Field Coordinator for West Virginia Rivers Coalition. Our mission is conserving and restoring West Virginia's exceptional streams and rivers. Part of that work is recognizing that in order to protect our streams and rivers, we also have to do work on our land, where our water comes from before it reaches streams and rivers for whatever their use is, if it's recreational, fishing, swimming, canoeing, or if it's drinking water. So a lot of my work is in the realm of source water protection, assisting water utilities and community organizations in working together. Renee, you were right on where I was going to go here with just thanking everyone for taking a time out of National Drinking Water Week to hear our presentation. Like you were saying, I really enjoy the slogan there when you need it. Not only are our water utilities, like everyone on this call, there when we need it year round, especially now during coronavirus. It's also the role that we try to play is being there when water utilities and their communities need us to assist them with source water protection activities. So when it comes to the Safe Water Conservation Collaborative that we'll be talking about today, our story starts back in January 2014 with the Elk River chemical spill. A above ground storage tank leaked into the Elk River, resulting in about 300,000 West Virginia citizens, or about 1 out of every 6 West Virginians being out of safe, clean drinking water for several weeks. So what that resulted in was Senate Bill 373, requiring all water utilities to have source water protection plans. Typically, when I do these presentations, we get into a little bit in depth about what those entail. I think most of the folks on this call will be familiar with those, but essentially plans that identify contamination sources and propose management strategies for mitigating their impacts on our communities' drinking water supplies. So that law went into effect in 2014 in West Virginia. By July of 2016, those source water protection plans went into effect across the state. As early as 2017, West Virginia Rivers realized by working with our communities and water utilities that, to no fault of the water utilities themselves, they often didn't have the staffing or the funding or often the jurisdiction to work outside of their municipal boundaries in their source water protection areas to fully implement their plans. So we formed the Safe Water for West Virginia program to do just that, assist water utilities across the state with finding community-based solutions to source water protection. And where I'm located is in the Eastern Panhandle. We formed specifically the Safe Water Conservation Collaborative. There was a lot of interest in co-integrating the work of water utilities and land conservation organizations, as well as the rich network of community groups that we have in the Panhandle, and find ways that we can work together on protecting drinking water through land conservation. So that was 2017. I was hired at West Virginia Rivers in the early part of 2019. We worked last year and the remaining part of this year, for the next couple of years on implementing some core objectives that I'll be talking about in the presentation today. So this is our vision statement. I'm not gonna read that, but the two things I do want to highlight here is we do strive to be a vibrant network. We're getting there. We've done a lot of work this year, and we'll present a little bit on that of what we've done to really build ourselves up. And at the core of the work is protecting safe, clean drinking water within our service area, which is Jefferson and Berkeley counties in the Eastern Panhandle of West Virginia. So we achieved that vision through accomplishing our mission, which is protecting drinking water through land conservation. And when I share this, I always like to do it in 2 colors. It's critical for us. Protecting drinking water is at the core of our work, and it's that our strategy is land conservation. And what we do mean by that are voluntary conservation easements, wherein a landowner can say, we want to permanently protect our land, and in doing so, the benefits that come with that for protecting our drinking water supplies. And something I like to show with that vision and mission statement is a branding image that was created out of a work group session way back in 2018, where all of the partners at that point got together and said, what do we want our brand to be? And I think this image that was drawn by a local artist at the time really captures it well, that protecting drinking water is at the forefront of our work. And behind that is a strategy, which is land conservation, protecting our streams and rivers, our natural resources, our farms, fields, and forests. So I think that does a really great job just in that image of capturing what the collaborative is about. And so as we're getting into it, there will be 3 times during the presentation where we're going to ask a polling question. And the first of those will be right now. I believe Renee is going to pull up her screen and give you all directions on how to take a quick polling question.
So if your computer won't let you choose one of the options, it's a GoToWebinar glitch. If you switch from maximize screen to minimize screen, you should be able to choose one of the options. Sorry, GoToWebinar glitch. We'll give you another 30 seconds or so to answer.
So as folks are reading that and answering that, the goal here that we're trying to gauge is by presenting to a wide audience of water utilities. Water utilities are at the core of our work. We'll talk about that as we move forward. It's our opportunity to perhaps gauge how strongly folks feel about a statement like this, that land conservation is a viable strategy for protecting drinking water sources.
All right, I'm going to go ahead and close it. All right, so there are the results.
Can you, I can't see them so clearly on my end. It looks like the 70% or so say strongly agree and another 20% say agree. So a pretty strong agreement that land conservation is a viable strategy for source water protection. Thank you everyone for participating in that. Hopefully that was an easy enough process for everyone. Are we back into viewing the presentation now, Renee?
Yes.
Great. All right, so there'll be 2 other opportunities throughout the presentation where we'll pause for something similar. So thanks for participating in that one. What we'll get into now are some of the core strengths that we have as a collaborative. And one of the key things is that it is a cross-sector collaboration where we're bringing partners together that haven't worked together traditionally in the past and finding real strength in that. So within Jefferson and Berkeley counties, there are 5 water utilities that are a part of our work. That are participating at the steering committee level. We have about 6 or 7 land conservation organizations, such as local farmland protection boards, local or statewide land trust, local historic landmarks commission, folks that really know our strategy of land conservation really well. We have some state and federal agencies like West Virginia Conservation Agency or Department of Environmental Protection, local conservation districts, folks to provide some technical assistance on the back end. We have organizations like West Virginia Rivers Coalition and others that are interested, generally speaking, in safe, clean water. So they're finding ways to participate and engage with the collaborative. And a smaller subset here, but an important one nonetheless, which is private businesses, that there is an opportunity with this work to build public-private partnerships and engage the business sector in source water protection. This picture I always like to show when we present about the collaborative. This is from a meeting that we had in September of 2019. We were, as a group, there's about 20 of us going over our short and long-term objectives. And at this one particular day, at this one particular moment, we did a thumbs up agreement. And we said, is everyone with us? Or are we all moving forward together? And that was a great moment to see that we all were moving forward together. Building success and agreement with such a wide-ranging partnership requires a certain level of just building trust, which is a constant and ongoing process. So the next couple of slides will go over some of the ways that we're working to build trust and build that success out in our community by working to clearly define the structure of how we're doing our work, creating transparency within the work itself, and then continuing to define and refine collaboratively our short and long-term goals. So regarding how we're structured, we have a steering committee that functions similar to like a board of directors for an organization to provide overall vision and leadership and guidance. Our water utilities serve on the steering committee, as do chairs of the 3 work groups. Today, we'll primarily be talking about some of the work of the conservation work group, but towards the end, we'll talk about what some of our other groups are working towards. West Virginia Rivers Coalition, the organization I work for, we serve as what's known as the host partner for the collaborative. So we provide coordination and meeting facilitation, general administration of grant funds, and then beyond kind of our core group of volunteers and community members that serve on the steering committee or work groups, we have a pretty big list of general membership to provide overall support and targeted engagement when there are things that we need. So this is something that's really came together in the last year or so since I've joined on. When it comes to fostering a true sense of transparency in the work, we do have a website, safewatercollaborative.org, where all of our meeting notes, all of our presentations like this one will be up there after today. All of our objectives are on there. We're developing resources for landowners on the site. So this has been a really important step for us. And we also have a document that was developed back in probably 2017 or 18 called Private Lands, Public Waters. This is our 5-year action plan. We do have exciting news on this front. We just learned this week that the EPA Region 3 Source Water Protection Team has committed funding for West Virginia Rivers Coalition to help support a strategic planning process for us in 2020 and 2021. So that's something exciting to for our collaborative moving forward, that we can take a small plan that was developed a few years ago and really build that out as we move forward and grow as a collaborative. I'm not going to read this slide as well, but the important thing to show here is that whether the collaborative is working on water policy or public awareness and outreach, or in general collaborating on land conservation, the through line of all of it is source water protection and protecting our drinking water supplies. So again, it's protecting drinking water is the work. That's what we're trying to achieve. And we get there through that strategy of conserving land. So what we're working on this year, moving forward, we have funding from the Land Trust Alliance and Chesapeake Bay Funders Network through their Chesapeake Bay Land and Water Initiative for three key objectives. The first is prioritizing high value land to conserve. This is what the majority of our presentation will be about from this point on. We're also working with our education and outreach work group on engaging those prioritized landowners in conversations about protecting their land. And then lastly, working with existing easement holders. There's currently about 100 or so conservation easements in these 2 counties, about 10,000 acres of conserved lands. How can we work with those landowners on educating them about conservation best management practices like riparian forest buffers or fencing cattle out of streams? Things that are good practices agriculturally that are also good for water quality, things that are addressed in our local source water protection plans. So we're going to do 2 things at this point. I figured we can pause for questions, Renee, if there are any questions at this point. And then after that, there's one more polling question before we get into our GIS prioritization model. So any questions at this point, Renee, that you've gotten in the chat boxes?
No questions, but I did want to note that we're seeing the presenter view. So we're seeing probably our full screen.
So you're seeing all of my notes.
Yeah.
So hopefully the notes are good. And let me see if I can change that. Is it worth changing? Let me see if I can. How's that?
There, that's better. We can see the full.
Now you see the full screen.
Yeah.
Very good. So no questions, so that's good. So we'll move forward. There's a second polling question where we wanted to just kind of gauge the participants and the benefits of cross-sector regional partnerships.
And again, if you're having trouble answering it, switch your screen from maximum to minimum. The screen that the webinar is on, and that should help clear the glitch. Okay, another about 30 seconds to answer.
And we would assume with this question presenting to a drinking water source protection partnership that regional partnerships are important to the crowd. So it's more so the question of the cross-sector portion of the question. Is it important to work beyond just water utilities, beyond just land conservation groups and community groups, but bringing multiple types of groups together to achieve greater levels of success?
All right, I'm gonna go ahead and close it. Tan, are you able to see it better this time?
Yeah, it's still small, but it looks like
Okay.
70, 80 or so percent say strongly agree, and again, 15, 20% say agree. So again, that's great. That's what we would anticipate hearing, but we really appreciate everyone providing that level of feedback in these polling questions. So are you continuing to see my screen there, Renee, the full screen version?
Yep, perfect.
Very
Thank
good.
you.
Okay, so at this point, we're going to be talking about our GIS prioritization modeling. Renee had asked us to present because the Drinking Water Source Protection Partnership, you will be looking at your own land prioritization modeling. So she wanted us to present on what we've done. And before I even start, I do want to say, again, for transparency's sake, all of this is on our website. We have a page dedicated to our prioritization process. We have a story map and an online digital map where you can read the story and explore the data. Those were developed by Chesapeake Conservancy as part of our Land and Water Initiative grant. And we also have a technical document, They Under Learn the Process. That's most of the slides that you'll be seeing in this presentation. So our process had 4 steps. And I try to break this down to try to make it understandable. The first thing that we wanted to do within Jefferson Berkeley counties, there are 85,000 property parcels, the vast majority of which would not be eligible for a conservation easement, or they wouldn't be of at least the most rudimentary interest for the collaborative. So we said we only want to target parcels that were greater than 20 acres in size and within drinking water protection areas. So I'll show some maps of what that looks like. This is just a map of all the parcels that are greater than 20 acres in size. I believe it was about 2,000 or 3,000, again, out of 85,000. And then also, we wanted parcels that were within drinking water protection areas, what would be referred to in the source water protection plans as zones of critical and peripheral concern or wellhead protection areas. And when we asked those 2 questions together, we ended up with a list of about 1,100 targeted parcels. So the thing I want to say here is keep an eye on these parcels as we move forward with the following slides. These are the parcels that we then further prioritize in our prioritization modeling. So you'll see these pop up again as we look at some of our different indicators. So we looked at 10 different indicators that would tell us important values about the land. What they tell us, we have 5 water quality indicators that generally tell us qualities of the land that are important, that would make it important to protect for protecting drinking water or water quality. And then in addition to that, we had 4 different programmatic indicators. These don't have anything to do with water quality, but they would make the potential easement easier to fund or bring partners to the table. So we were cautioned as we move forward with this, don't just focus solely on the water quality, also focus on what brings potential funders to the table to make that prioritization process grounded in reality. So I'll talk about that moving forward. And lastly, geographic indicator, there's one of those, some priority watersheds that we wanted to work in. All of this was done through a collaborative process through our conservation work group. We did a lot of data collecting of what data sets were out there, spatial data sets we can use in GIS and computer mapping software, that is. And then we did some surveys of which ones floated to the top for us for our group. And so there'll be some tips at the end for you all as you move forward with your own land prioritization modeling. But the biggest one we heard from folks is this changes based off of where you are and what the partner's interests are. So make it your all's. And that's what our partners did. We captured that via a survey. So I'm going to show slides that show maps of the 10 different indicators. And so again, those 1,100 targeted parcels are shown on all of these maps. This map, this first indicator was karst geology. You can see in that light green color, that's where we have karst geology. In the dark green color are parcels that have some acreage of karst geology, and then the ones in pink are still our targeted parcels, but they do not have any karst geology. So we'll show similar maps moving forward. The measurement here is acres of karst, and the idea was we would want to prioritize parcels that have greater acreages of karst geology. This is something that land conservation organizations already measure, so it was a pretty natural fit that we would want to prioritize this in our modeling. The second, when it came to protecting drinking water through land conservation, was riparian forest buffers and having healthy streamside forests as an indicator of clean and healthy streams, clean, healthy water. So again, the targeted parcels that are in pink don't have any riparian forest buffers. You can see the ones in dark green that do. So that was another one. Correlated pretty closely with that is streams, but instead of looking at acres of riparian forest buffers for this indicator, we were looking at linear feet of stream. Again, higher priority going to parcels with greater linear feet of stream. The fourth water quality indicator, this one always takes a second to explain, is development. Another way to look at this is urban sprawl, as what we are measuring here is changes in household growth. And so we know in general, land conservation, inherently what you're doing with land conservation is voluntarily conserving your land and extinguishing the development rights to your land. So we wanted to find a way that we could capture this in as locally derived of a process as possible. We wanted the data to be derived locally, not a national data set. So what we did, we pulled together two local data sets. The first being, where do we want growth to occur in Jefferson and Berkeley County? So Jefferson County, the county here in the image to the east, has zoning, so it has a slightly more succinct planned growth areas. Those are referred to as urban growth boundaries. You can see there's one from south to north, Charlestown, Ranson, and Shepherdstown. And that's where our county is saying that's where we want growth to occur. And you can see there are some targeted parcels that are still in that pinkish purple color inside of those areas. Outside of those areas, there's a data set from the local metropolitan planning organization, their long-range transportation study, where one of their metrics that they were looking at is changes in household growth. So by putting these, and I should say the darker areas are where they expect more houses to come up, the light yellow areas are where they're less. So by putting these two data sets together, we could say we want to prioritize conserving land where growth is projected to happen, but where our local planning institutions say they don't want it to occur. So within those planned growth areas, we're saying that's not our priority. Our priority is outside of those planned growth areas, in the dark brown areas where there's a great change expected in household density. So that was our water quality measurement for development. And again, the correlation being with more houses, more parking lots, more impervious surfaces, we're gonna have more stormwater runoff ending in our streams and making it to the water intakes. So that's our fourth water quality indicator. And our fifth was tree canopy in general. So beyond just stream side vegetation, 100-foot buffer on each side of the stream, our measurement for riparian forest buffers, this is tree canopy as a whole. Again, we measured acres of tree canopy as healthy forests are critical for clean water supplies. So those are our 5 water quality indicators. And now we're going to get into some of the programmatic ones that we looked at. The first being proximity to protected lands. So I'll explain it once for this one. Again, there's no correlation between proximity protected lands and water qualities. But what it is saying is by creating denser clusters, there's added value to that, and that is a measurement that local land conservation organizations value when they're looking at potential easements. So in pink, you can see where we have existing easements. The targeted parcels that are in that darker blue color are adjacent to those, and then the lighter blue colors get further away. And we'd say we would want to prioritize properties that are close to other conserved lands. Jefferson County has a rich, and Berkeley County to an extent as well, have rich Civil War history. And again, when we talk about funding, there's battlefield land acquisition grants from the National Park Service. So this is just a way of saying, again, no water quality benefits from protecting Civil War battlefields, but it does make a potential easement more fundable, brings people to the table to make our strategy a reality. So we would want to prioritize in this instance parcels that have Civil War battlefields. And one thing I'll say here too really quick is for some of our measurements, they are acres of karst or linear feet of stream. For this, it was a simple yes or no. If it had 10 acres or 100 acres of a Civil War battlefield, we couldn't get into the process of qualifying that. It might have been a significant 10-acre battle or a slightly less significant 100-acre. So we just wanted to say, if there's any Civil War history there, that's valuable for us to protect. That's a priority. Another thing local land conservation organizations look at, especially farmland protection boards, are prime soils from the National Resource Conservation Service, what's called a SERGO database, saying we would essentially want to conserve prime farmland and keep our agricultural lands conserved. The fourth programmatic indicator is a data set from West Virginia Department of Natural Resources, their diversity, or I should say biodiversity data set. The parcels that are in yellow have some acreage of biodiversity. The little squares or 500-meter grids where they say if there's locally significant, globally significant, et cetera, areas for plant and animal biodiversity. And then lastly, again, we have three priority watersheds, starting from the west and kind of going clockwise. The Opacan Creek watershed in Berkeley County. There's multiple groundwater sources for about 40,000 residents that are drawn from kind of that area. Additionally, it's one of the National Fish and Wildlife Foundation's priority subwatersheds. So that was an important factor as well. The Elks Run watershed, it's a relatively small watershed that serves a relatively small water utility in Harpers Ferry, about 800 residents. But the key significance there is because they have Harpers Ferry National Historical Park, there's about 500,000 folks that come there every year relying on the Elks Run to be safe, clean, and drinkable. And then lastly, to the southeast is the Bullskin Run watershed. It flows into the Shenandoah River directly upstream of another slightly larger for us utility, Charlestown Utility Board, about 15,000 residents there relying on safe water coming down the Shenandoah for them. So those are our 10 data sets that we look at, and I hope that was the right speed. The third step that we did with those is assign 0 to 20 scores based on some defined thresholds that we set. So if you can imagine, they're apples to oranges to try to add them up together, which was our final step. We can't add up acres of karst with linear feet of streams versus yes or no for Civil War battlefields. So we had put them all to 0 to 20 scores. I'll explain, for karst, if it was 0 acres of karst, you got 0 points. If it was more than 200, it got 20 points. And then some other thresholds in between there. And then what we did at that point was take an additive approach. We added those 10 values together, 10 values on a 0 to 20 scale. The maximum score would have been 200. Parcels closer to that maximum score of 200 were our priority. And this is the results. This is what that looks like. And as you're looking at that, I will say again, this is available on our website as an interactive online GIS map where you can zoom in and out, click all of those layers I just showed on and off, and explore the data. So on this map, parcels that score more than the top third or 123 points or more were our priority. There's about 37 of those. Those are the ones that we focus our outreach on moving forward. And I will pause it here. We have a polling question right after this, but I'll pause here for questions because that is the more technical part of the conversation. Are there any questions on your end, Renee?
I haven't seen any questions, but I actually have a question.
Sure.
Have you shared this GIS layer with any of the planning commissions or any of the websites that people go to for planning?
No, that's actually came up. We presented to the, I'm gonna get the name wrong. It was the Chesapeake Bay Program's Maintaining Healthy Watersheds Goal Implementation Team. And a similar question came up with that group, and it was kind of the first time that sparked for us that in a circular roundabout way, we can use our own process of digging into this data to help inform those planning processes locally. So I would say it's not a strategy we will be working on in the short term, but it is something that's came up multiple times. At the very least, the need to do like we're doing now, which is just informing members of the community about what we're working on, I think there is strength in that. So hopefully we get to that sooner than later, whenever things start opening back up again.
Yeah. A few more questions are rolling in.
Sure.
What water quality parameters were considered but not used, and why?
Let me scroll back and time check me whenever you need to. Renee, please, that won't bother me. So you can see on the left-hand side of the screen here, the ones that are kind of in that green perforated line were the 5 we used. So you can see wetlands, soil erodibility, the 100-year floodplain, and there's another one that's cut off there, wetland soils, which was a different classification. And those just didn't float to the top. I don't have the specific, like in mind, this was from back in October, I don't have the specific reasons. But I can say this survey, there's a hot link in this presentation you can see up top, but this is also on our website with all of our meeting notes and surveys if someone really wanted to dive in. And again, our challenge here, our first step was trying to conglomerate all of the available data sets. And those were the ones that we had found. I will say, as the questions are coming in, one of the things I'll mention in a second is we do have a survey open, and Renee is going to share that out with everyone on this call afterwards, where we're trying to collect from our community feedback on ways that we can strengthen this model moving forward. We've been very open in all of our documentation about this, that this is our GIS Prioritization Model V1. This was our first attempt at pulling these data sets together and putting our minds together on this, and we do want it to be a live process that grows and evolves over time, that we can open the book on it again with new data sets. So those are the water quality indicators, and you can see for the programmatic indicators, the one on the left that's not circled there, parcel size, we incorporated that as one of our original filters in step 1. So parcel size was looked at, but not as a programmatic indicator. And the 3 that kind of fell a little bit lower were sites that are on the National Register, looking at climate resiliency, and community demographics. And again, all of our comments that we receive from folks are available on our website from the survey. Any other questions I can answer, Renee?
Yeah, we have one more. Are the easements customized to address source water protection?
So I would say the easements are whatever the landowner wants them to be. I think in my history with this, and I've been here since about a year now, is our process is engaging the landowners in conversations and doing that pass off to local land trust and farmland protection boards. And as they have those conversations, they continue to own the land. They continue to maintain the land for all of its current agricultural uses. For example, they can set aside areas where they might, need to put a shed in the future. It's very customizable. It's very personal, the process. And I do think there's places in there where they can, that first step is prioritizing your values. Why do you want to conserve your land? And then tailoring the easement around that. But that's where our process ends as a collaborative, is engaging them in those conversations and doing the pass off to the land conservation organizations that really know the lingo, that really know the process, and that can take them, from the initial interest that we hope we generate to the final product of conserving their land. And I'm very happy we have some land trusts of the Panhandle folks, I believe, on the call. I hope they're not cringing too much with that answer. They might be able to put into the comment box if there's anything I didn't capture as well.
Okay, I'll watch the comment box, see if they have anything else to say.
Alrighty.
And then one last question, and if you're comfortable sharing this, go ahead. If not, you can pass it up. What was the cost of the whole mapping project? You remember?
So the mapping was all done in-house by me. The process was all done collaboratively. Like to develop it, we didn't hire a contractor or anything to do that. It was, we coordinated and facilitated the meetings. We talked to the work groups, ran everything through that structure, and then I did the mapping and put the presentations together, et cetera. So I don't have an answer for what that would look like for you all, only because we did it in-house with our grant funding that supports my position.
Okay, that makes sense.
Yeah.
Okay, that was it on the questions. You ready for the next poll
All
question?
right. Yeah, one last poll question before we wrap up. Renee will pull that up.
And if you are still having, if you've toggled your screen for maximum to minimum and you're still having issues, can you raise your hand just so I can have an idea of how many people are not able to complete the poll? Okay, it looks like a few of you still are not able to. I wish I had a better answer, but all right, about 10 more seconds for those of you that can. I'm going to go ahead and close it. We have about 67% strongly agree with the statement and 30% agree with the statement.
Renee, I just think you have a really agreeable group today. But well, it's really good to hear that. So thanks for the questions, and that's the last polling question for our presentation. Let me wrap up with a couple of final slides here. So again, we talked about our 3 objectives. I'm going to elaborate on those a little bit. We have completed our GIS prioritization model. Like I mentioned, it is very strongly a V1. We have the survey open. I mentioned that before. I would encourage everyone on this call to please take that survey. It would only take you about 5 minutes, but any insight and feedback we can get, especially from water utilities, is really helpful for us for strengthening this work as we move forward. So Renee will share that out after this meeting. For education outreach work group, we've taken the prioritized landowners and created what we've called a landowner outreach matrix. We did a survey where we said who knows who within our community, who is our best contact within our partnership to reach out to these landowners to have a friendly one-on-one neighborly conversation as opposed to a cold call. And we were working on planning 3 outreach events for this spring when the shutdowns began. So we're going back to the drawing board a little bit and working on some new strategies for outreach and ways that we can engage those prioritized landowners in conversations about land conservation. And then lastly, for our stewardship work group, we're working on developing a toolkit. All conservation easements have to be monitored annually. So as someone is on the land with the landowner, we're developing some tools that they can educate them about best management practices that they can do on their land, again, that are good for their farm, good for their land, and good for water quality. On the steering committee level, we've recently finalized an operations guide. This is another important structural piece. And then, like I mentioned, we're working on developing a long-term strategic plan, a strategic planning process over the next year or so. And then I wanted to end from our conservation work group who did our land conservation or land prioritization model. They wanted to provide some feedback to the Drinking Water Source Protection Partnership as you all move forward. We would hope that we could serve as a resource as you all work towards that. A couple of things that they mentioned when they read through what Renee had sent to me, it was like a 1 or 2 page kind of outline of that work. Is to really consider karst as one of the indicators that you all look at, primarily for you all down into the Shenandoah Valley. There's a lot of karst, and there's really strong correlation between contamination events on our land, especially in karst environments, and very rapidly being able to infiltrate through karstology into groundwater supplies, which then interact with surface water. So consider karst. Summing it up, turn your maps and your prioritization process into money. We would hope, as this regional partnership that you all are, that you could leverage your analysis to help raise that capital to support land conservation initiatives across the watershed, including up here in the Potomac headwaters in West Virginia. Like I mentioned with our programmatic indicators, this was recommended to us, so we'll share it as well, but grounding it in reality, we think is a good strategy. Just making sure that as you're looking at what's good for water quality is also feasible and reasonable, and that you have folks on the back end that are going to be interested in that work. It's not just a kind of a high-minded concept in water quality, but that it's grounded there in reality. And the last one here is we're all walking the walk really well and doing these land conservation, land prioritization modelings, but we have to also talk the talk. So, analysis is a good first step, but all of us, and very strongly, including me and including the collaborative, we must find ways that we can educate and work with water utilities and speak their language and really bring them along with us and make sure we're all moving forward together. Source water is the root of all of this, and even though land conservation groups have the strategy in pockets, it's the water utilities and their customers, they're real beneficiaries. So finding ways we need to find ways to do what you all do really well, which is really engaging water utilities and bringing everyone forward together and conveying the importance of this on a regional scale is what's going to really drive success. So that's our last slide. We're on my screen about at 42 minutes. So we have just a minute or two if you do have any other questions that have popped up, Renee.
I have one last one. I'm not sure if you can answer it. If you can, great. If not, I will try to find the answer and I'll get back to the asker. Can land conservation be used as a way to comply with MS4 urban permit restoration requirements? And are urban permittees potential funders of land conservation?
I can't answer that. I would rather not answer it than fumble it. But what I can commit to doing is I will contact our local MS4 folks in the city of Martinsburg in Berkeley County that we work with often, and I'll ask them that question. Do you mind emailing me that question so I make sure I get it right, and then I'll respond to you, Renee? You can share it back out with whoever's interested.
Yep, I will do that.
Okay. That way I don't give a half right or half wrong answer. But I think it's a good consideration, and it is at least again here in West Virginia, like I mentioned, in Martinsburg and in Berkeley County as a whole that Martinsburg is within. They have MS4 programs that really bring strength to reducing stormwater runoff in our region. And again, if we're reducing stormwater runoff through land conservation, maybe there is a fit there. So let me look into that and I'll respond to you directly, Renee, that you can share back out.
All right, great. Thank you so much, Tanner. It was a lot of great information. Thank you all for
taking the time during Drinking Water Week and for being a part of the Drinking Water Source Protection Partnership. If anyone has any follow-up questions, you have my contact information here. It's also up on the Collaborative's website. We hope you can get up on there and explore. And if you have any questions, just feel free to reach out to me directly.
All right, thanks. I'm going to go ahead and switch the screen to Dr. Locker.
Okay, hi.
All right, hi. We can see you and your PowerPoint. If you want to make the PowerPoint bigger, then we could probably read it a little bit better.
Yeah. Okay.
Perfect.
Can you see the little webinar thing on the side too?
No.
Okay, you can. Great. All right. Welcome, everybody. Thank you, Renee, for inviting me to give this presentation and for the nice introduction as well. So my name is Dr. Locker. I'm program scientist for the Changing Landscapes Initiative. Like Renee said, we're based in Front Royal at the Smithsonian Conservation Biology Institute, and we work on science to support decision-making for change. So I'm just going to give you a brief outline of what I'm going to go over here with you today. Introduction of who we are, our goals. CLI is the Changing Landscapes Initiative. A bit of a background, give you a summary on our approach and our research, and then talk a bit about how Changing Landscapes Initiative could be used as a resource or a collaborator for some of your efforts. So our mission is to combine scientific rigor and community wisdom to help secure a vibrant and healthy future for people and wildlife. We understand that biodiversity is the underpinning of ecosystem function, and ecosystem function is what produces the services that we need in order to thrive. So a basis of my research is the understanding that our quality of life is securely tied to both the economic and environmental health of where we live. So ecosystem services, as I mentioned, are underpinned by biodiversity. And what we're really interested in doing is producing science that would help us understand the potential impact of land use change on ecosystem services. So this is what's at stake. It's these shared natural resources, natural processes such as climate regulation, flood mitigation, and crop pollination, contributions to physical and mental health, in other words, access to green spaces and genetic resources for medicines, social, educational, and cultural benefits, and of course, last but certainly not least, and arguably one of the most important, is natural resources for basic survival, such as clean air and water. This is a map that shows the general vicinity of where we work. Currently, the Changing Landscapes Initiative has been focused for the past 5 years on a 15-county area surrounding the Shenandoah National Park. This map shows how much of this 15-county region actually rests within the Potomac watershed. So the Potomac watershed is the light blue area on the northern part. We are looking at this region as kind of a pilot study to test an approach for both community engagement in the co-production of science and also the application of this science in policy and planning. So this is just what I hope to be the beginning of what we do. I'm going to see if this plays for you all. This is an image from Google Earth time-lapse that illustrates change happening around the Washington, D.C., Baltimore area. And this is between the years, let's see if I can, this is the years between there we go, to 2016, I think it's 1986, the first year. 1984, there we go. So you can see how rapidly this landscape is changing. And so Washington and Baltimore are actually on the northeastern corner of a 15-county area, and we've got many counties that are experiencing the impacts of development pressure and population growth from this region and are interested in trying to understand how to conserve their natural resources. So the question really is, how will the land use decisions that we make today impact the things that we care about tomorrow? And what can we do as scientists in order to support planning for the future of our home? So this is where our goal is. The goal of the Changing Landscapes Initiative is to provide objective information on the potential impacts of land use change on the local landscape. So fundamental to our process is a combination of people and science together. Conservation is a social field. It is essential that we work with people in order to produce science that will bridge that science policy gap that has been so challenging for many years. And we do this using a framework called scenario planning. So scenario planning is actually a structural way for organizations to think about the future. It is an envisioning exercise where you develop different narratives that describe potential futures. So it provides a strategic forecasting and long-term guiding framework that allows you to consider the uncertainty when thinking about future decisions. It was originally developed by the military in, I think, the 1970s, and then taken up by many, many corporations. Now is essential for businesses in their operations. So what we do in the framework of scenario planning is to convene regional experts and community leaders to develop scenarios for the future. at a 50-year timeline from 2011, which puts us at approximately 2060, and to support those scenarios with science. So the people that we work with include county and regional planning, county committees, conservation and land management organizations, public lands, and then finally advocacy groups. So this is some of these logos are some of the active collaborations that we've had over the past 5 years. Now, our scientific approach, it's really about collecting data, being objective on our understanding of how drivers of change might influence land use change in the future, understanding and quantifying all of this using historic patterns of change, and then apply this to model future land use change. And then with that, we take those results and we evaluate the impacts of land use change on ecosystems, all while considering and incorporating the idea of uncertainty when thinking about the future. All right, so I'm going to get to some of our results now. This is the result of a scenario development workshop that occurred in 2016, where we brought together over 40 experts and community leaders within the region to develop a suite of scenarios that described potential plausible futures for the year 2061. So I'm just going to walk through real briefly these scenarios with you. What we did was to identify what are the primary drivers of change for this region that we work in. And the stakeholders decided that this has to do with population growth and also political will, or the way you plan or your ability to plan for the future. So that's these two intersecting lines here from north to south, east to west. These describe the intersection of those drivers and results in 4 scenarios for the future, in addition to one that's guided by business as usual, which is not shown on this screen. So scenario 1 is the one on your top right. This is where development is focused around urban centers, agriculture is maintained or increased, resulting in a flourishing job market. This is the intersection of high population and strategic planning. Scenario 2, to the left of that, is high population and reactive planning. In this scenario, development occurring along the roadways results in increased parcelization or the breaking up of land, and this increases forest loss and fragmentation. This also increases potential pressure and costs for municipalities and counties to maintain and develop infrastructure. Scenario 3 is below that. This is a scenario with low population growth or stable population growth and the reactive planning. In scenario 3, the region's resources, good soils, productive forests, and water are extracted to support other high population areas like DC. In this scenario, industrial scale resource extraction overruns traditional agriculture. Now the scenario to the right of that, scenario 4, is the result of strategic planning and low population growth. In this scenario, the movement of younger generations from rural areas reduces the need for new infrastructure, though strategic planning preserves open space, forests, and family farms. In this scenario, the economy may be largely driven by local agricultural practices and tourism. Okay. So we need to take those qualitative scenarios and then turn them into quantitative values in order to translate them into model projections for the future. So I'm going to leave my screen real quick and take you to what we've developed is a sliding map for 2 scenarios, comparing high population with reactive and strategic planning. So I hope you can see this sliding map right here. Renee, is this visible?
Yes, we can see it.
Okay, great. So here we have, this is 2011 to 2061. So on the left-hand side, you can see 2011. This is the National Land Cover Database. And then on the right is our scenario for high population and reactive planning. So as I move the slider, then you can begin to see what the changes look like. Now to give you a bit of a guidepost, green here is forest. Yellow is what's considered grasslands or pasture or hay. It includes alfalfa. The orange color is considered cropland or row crops. And then the dark gray is what is development, which is the low, medium to high development for NLCD. So again, in this scenario, with the reactive planning, with the guidance of the stakeholders, this means that development is occurring along major roadways instead of clustered near existing urban areas. So you can kind of see that difference right there. Now, I'm going to flip over to the next one. This is also up to 2061, so in the future. This is high population, and this is strategic planning future. So this is going to be the same number of people, but you know, how development has been approached is for it to be more focused and centered close to urban areas, and also increasing the density where zoning allows for it. So you see, you know, this is really visible here in Frederick County, Virginia, where on the eastern side of the county, that's that triangle, the big point on the very top, for those of you who are not as familiar as I am after staring at this map for 5 years. You can see that the development in this case is really clustered around, that's Winchester. And then on the eastern side there with Loudoun, near Washington, DC over here, you can see how it's more clustered along existing urban areas than, in this case, the reactive planning. You can really see the spread. All right. So the next stage here is to evaluate the impacts. It doesn't stop at just mapping land use change. I find those maps can be particularly helpful for planners in order to figure out how, you know, questions of what is the impact of zoning on the future? How does our zoning compare to the results that you've developed with these projections on your maps? But what we really care about is, you know, what's the impact of this on the things that matter to us in terms of survival and human well-being? And so it's really a simple equation to figure this out. It's composition, which is how much, plus the configuration, where, is what contributes to landscape function. So this is important to remember. Here we have scenario landscapes. On the left is observed in 2011. This is the change in development in stream catchments. So development growth in the study area. In the two right maps, you have those two scenarios I showed you on the sliding maps. So high population strategic planning is that middle map, and then the right map is high population reactive planning. And you can see between the two of these, I've highlighted a few areas, how you can really see how the difference in planning strategy affects where development happens. And then the bottom, I've given you some numbers for the total increase. Now, in a course of 50 years, the increase of, you know, what is that, 15,000 or so acres over this entire landscape doesn't seem like it's actually that much. Now, don't forget, development doesn't actually take most of the landscape for us. There's a lot of agriculture here and forests, and what really matters is both the amount, but also where that change happens. So, Renee, I am wondering if you could show the polling for question number 1.
Sure. All right, it's up.
So this question for all of you, I'm going to do this one and then another one a bit later, are how open are you to partnerships and collaborations with local scientists? So I've shown you some of our land use futures, and I'm about to get into the ecosystem services impacts. And I'm curious about, before I even dive into that, what your view is with regards to collaborating with groups like ours.
Okay, another about 15 seconds or so to answer. So we'll have some votes rolling in. Looks like some of you have figured out how to vote, which is good. Okay, I'm closing it now. And can you see that, Dr. Walker?
No, I can't.
Okay, we've got about 57% extremely, 34% very, and 9% neutral.
Okay, great. Thank you, everybody. Okay, moving on to some of the impacts. For this audience, clearly water quality is on the forefront of my mind. So you all are probably familiar with Chesapeake Bay TMDLs and what some of the requirements are for the reduction of total sediment, nitrogen, and phosphorus. So this really matters because what we need to see, therefore, if we're shooting for these goals, is a reduction currently from now into the future, from the business as usual scenario for the very least. And what we've seen is that even with business as usual, there is an increase in total percent. So it's actually adding to the difficulty of reducing total sediment, nitrogen, and phosphorus for these counties. So I'm going to show you two approaches. The first is from Virginia Tech, which actually looked at water quality across land-river segments, which is the intersection of county boundaries and watersheds. This, again, is the high population across two scenarios with the change of total nitrogen in the future. So the left is low political will, the right is high political will. So here you can see that I'm not going to focus entirely on the counties. You're welcome to get these results from us, but there is an effect of sprawl and the approach to planning across these scenarios. What resulted from this study is this understanding that the approach to planning is actually more important to water quality than total population growth. So the next approach was completed by USGS, and this allows us to have a more specific focus or localized focus of impacts of land use change on water quality. So instead of looking at these larger watersheds and county boundaries, we're actually looking at sub-watersheds and stream segments. So with USGS, they looked at floodplain deposition and bank erosion rates. So really, this comes from two things. They use routes. So if you take a cross section of a route along a stream bank, then you can get an estimate of how much sediment has been lost from that stream bank. And this is because exposure to the atmosphere and the change in support from the surrounding or lack thereof soil causes anatomical changes at the cellular level, which allows us to identify the timing and total amount of change in sediment. So why do we care about sediment? Sediment characteristics are important. There's impacts on biota. There's associated contaminants that can ride on these sediments, impacting water quality within a stream and within floodplains, and therefore also potentially for drinking water. So the USGS looked at long-term stream bank and floodplain characteristics and sediment and associated nutrients at 68 reaches across the United States and Mid-Atlantic. And then these sites are representative of the total variability in watershed drainage area, geology, topography, soils, hydrology, and land use. They took this and then applied our scenarios within our study region to understand the potential impact of land use change across those scenarios in order to guide planning. They used this floodplain and channel evaluation toolkit, which actually takes LiDAR images of stream banks that allows you to capture some metric of geomorphology or the shape of the stream bank. And then developed GIS shapefiles and tables with certain characteristics that then allowed us to plug this information into the model and develop outputs for sediment, nitrogen, and phosphorus along stream banks and also floodplains across our area. This is very simple diagram, but it gives you a nice understanding of this is how sediment flows across the system. And for all of you, I'm sure you're all very well versed in this, but water goes down the hill, flows downstream. So takes sediment with it. Some of it is deposited in a floodplain, and then some of it is actually transported downstream, and that's the TMDLs. So now I'm gonna walk you through a few graphs. This is, I'm gonna go slowly for this, but this actually illustrates the impact of certain land use classes on what they've measured for each of those measurements. So this, for example, is bank sediment flux. This is the total amount of sediment that's being taken from the stream bank in kilograms per meter per year. So let's look at both of the axes. On that left axis, you can see it's got negative numbers. It goes from negative 55 on the top to negative 85 on the bottom. The more extreme the negative number, the more sediment is being eroded from that bank. Now the x-axis, this is the percent of grassland within that watershed. So higher number is higher percent. That red box is highlighting a threshold that our USGS scientists put in there to kind of illustrate a point here, where you can see that with less grassland in the watershed, you have less bank sediment erosion. And then there's a point at which it drops significantly and then stabilizes again. So that's approximately 25. This is the kind of information that can guide. It's not just about what the map looks like in the end, but our understanding of those underlying variables that drive the results. So we can then take this kind of information and apply it in other regions or places that are more specific to what you or your organizations care about. So here's another one. This is the same kind of idea, the same metric, but instead of showing you grasses, I'm showing you percent developed. So this is the NLCD developed land, so not open space, which is, I think, 20% impervious surface or higher. So again, left axis, more negative is more erosion, and then, or the y-axis, and then the x-axis is percent developed in the watershed. So in this case, he's also highlighted this red box to illustrate a threshold period. So it looks like it gets to approximately 28-ish% developed in the watershed, and then beyond that, you have significantly more and higher rates of bank sediment erosion in that watershed. Now here, I don't need to walk through these so tightly, but I wanted to show you the nitrogen and how actually you can use this information to identify trade-offs with respect to land use types and their impacts within those watersheds. So here we have 3 graphs. We've got percent developed on the left, percent row crop in the middle, and then percent forest on the right. And the important thing here that I wanted to communicate is simply that you can see that there are reversals in the trend line itself. So if you look at developed and row crop, for example, you can see that as it increases in percent totals within that watershed, the amount of bank sediment flux increases pretty significantly at a lower level, and it goes down. And then with forest, it's the opposite effect, which makes a lot of common sense. Okay, just to revisit the narratives again, so that before I move forward for the next phase here, here they are. And while I sit on the screen, I would like, Renee, could you pull up question number 2, please?
All right, we have about a minute to answer it. You guys are getting faster in your poll answering. I'm going to go ahead and shut it down because it looks like nobody else is answering. There we go. So how valuable do you consider scenario planning as an approach to long-term water conservation? We have about 22% said extremely, 69% said very, and 8% said neutral. And no one said not very or not at all.
Okay, thank you, everybody. Okay, so scenario planning is, the idea here is that we aren't planning for a specific future here. We could pick scenario 1 and we could say, given what I've seen in the outputs of these models, I would like that future. You're looking at you're looking at 17,000 plus square kilometer area that we've looked at in our study area. And every single county and every municipality there are planning groups of counties that have different approaches and different needs with regards to the communities that live within them. So it's not really realistic to say for this entire region, we're going to shoot for planning for a particular scenario. What it does give us, however, is if you imagine working in the present and then when you get to the future, there are multiple different decision points that happen, and there are multiple different players. Politics, shifting perceptions, everything plays a role in what results with regards to land use on our landscape. So for example, if you were to think back through your life 20 years ago, 25 years ago, I don't know, there might be how many different decision points could have led you to be in a different place than we are right now. And that's kind of the idea. It doesn't, it means at every single one of those decision points, you have an opportunity to evaluate what that decision might mean and then make a strategic choice moving forward. So the real future is these scenarios, but we can maybe pick the features of each scenario that we think suit our needs, and then work towards that, identify the major players and the decision points within the timeline, and then try to prioritize that. So I want to show you the maps for that same kind of data that I showed you with regards to water quality. Here is horizontal stream bank erosion. This is literally what you would see in stream bank erosion is the amount of land that is lost in centimeters per year along the stream bank. So this is 2011, this is current, and this is produced by the USGS. I hope I'm doing them some justice in presenting their data. This is change. So this is 2011 to 2061, that same metric. This is the high population strategic scenario. And red is more change, blue is less change. Here's the high population reactive scenario. You can see the Potomac River watershed outlined in light blue. So I'm going to flip back and forth. Here's strategic, which again is the clumping of existing or new development near existing urban areas. And then reactive, which is the idea of new development occurring along roadways. Here is the next metric, nitrogen flux. This is 2011 or current. I think that you may be able to see, if you know the Shenandoah Valley, significant amount of nitrogen change, nitrogen flux along the river. That's that line, red line going through the region. Now here is change between 2011 and 2061. This again is high population and strategic. So clumping of development. This is high population and reactive. What we're learning here is that development doesn't have as much of an effect on nitrogen as it does on sediment, which would, again, I think make sense to those of you in water. And that crops and pasture do. Okay. Now the issue is that I love maps. I understand them. I can see myself on the landscape when I look at a map, but a lot of people cannot. They really communicate, they don't communicate feel, they don't communicate sense of place. It's really hard for most people to imagine what that kind of change actually looks like and the potential impacts of it on their life. So we needed to work with visualization experts to develop tools that would not only be useful for planners, because a lot of planners, I think kind of you go into planning because you also like maps, and you have an understanding of land use and its impacts and zoning. But those planners, those decision makers need the support from the public in order to make change, that would support the needs of the people that live within their community. So this is an image from Massanutten. This is on the southern part of the Shenandoah. And this is just an example of how we can take our models, and so this is informed by the data, the real data that we've produced, and then create a visualization tool in order to gain public support for our science. So what I would like for you to do is, if you could just focus on the center of the screen there, beyond the forest, there's a little bit of population, there's some open fields, but really like the center area there, okay? Next, this is the reactive planning scenario. Now this is in the lower Shenandoah, so this is not even our high population areas in the region. But this was guided by our data, with the support and collaboration of people who know land use and planning in that region. So we have the full support of them to use this information. That's the reactive again. All right, now I'm going to switch over to strategic. Same amount of people, just a different approach in planning. This makes people gasp. This evokes emotion. This gains public support for planning. So this is how we are learning to take our science and connect it to the community, develop tools that can get them support for their work in addition to providing an audience for our science. That's where we take this data, tether it to plausible, relatable stories about the future, co-developed by regional experts and stakeholders, produce data-driven and objective map projections of land use change, and then connect it to imagery that allows people to feel and react to changes in their home and their sense of place. So I want to communicate a bit of just directly what I believe our value is, what our value could be for you all, our value could be for conservation groups, planners, utilities. And so that is, one, to provide information to aid the prioritization of your efforts. Resources are limited. We don't have enough people, we don't have enough money, we don't have enough funding and time. And so how can we best achieve the results we need in the most efficient way? We provide objective data. We can help you assess the impact of policy on water resources. Provide information for long-term strategic water management plans that take account of future uncertainty and are supported by people in the community. Encourage and support cross-country collaboration. Provide a vehicle for discussion about shared resources like water. Determine how local comprehensive plans can fit into the big picture. So imagining that counties, although they make decisions that are specific to their county, do not in reality exist in isolation of the surrounding landscape. And then help evaluate trade-offs between different land uses in particular locations. And then our scenario projections can be used as a tool for outreach to gain support. So before I keep going, I'm wondering, Renee, if you could just put up question 3. And this is our last polling question for this presentation.
All right, it's up. We have about 45 seconds to a minute. Seems like most people answered it pretty quickly last time. All right, I'm going to go ahead and close it in a couple seconds. The question is, how valuable do you find land use models when planning for water conservation? 36% say extremely, 61% say very, 3% are neutral, and there's nobody for not very and not at all. Thank you for everyone's input on all of these polls. I really appreciate it.
Yeah, same here. So I showed you a presentation on water, and I'm not going to walk into a presentation on all of the additional ecosystem services that we're looking at. But we are working with Furman University to produce similar kinds of results. We've just completed the analysis for this for recreation, carbon storage, pollination, and risk of habitat degradation. And as a reminder, all of this is underpinned by the biodiversity, which provides the function for the systems that then sustain the production of those services. So I'm also looking at, what is the role of biodiversity in maintaining that function? How does future land use in our scenarios, how does it potentially impact the spread of invasive plants? the distribution and abundance of mammal species. We've finished a paper on that. We're finishing up our study on invasive plants. We're looking at how it changes bird communities for biodiversity and also those birds who are at greatest conservation need. We're looking at pollinators, specifically bumblebees. And then finally, last but not least, my favorite pet project is the role of forest orchids on serving as an early indicator for changes in forest health. One of the big goals of my research is really to produce information that can be taken and used in planning and policy. And I like the idea of approaching science in this rapidly changing world in a way that we can actually use the resources and data that we've currently developed, so that it's not necessarily the perfect model, it's not necessarily the exact prediction of the future, but it provides enough information for us to act in quick enough in a way that we can actually use it when we need it the most. I would like to give a big shout out for our two biggest supporters. These are where our members of our core advisory group come from. These are two of the largest organizations in conservation in the region. The Alliance for the Shenandoah Valley, that is our representative for that valley region, and then the Piedmont Environmental Council, which we've got some great support from them for the Piedmont region. And then I'm just going to wrap up. I'm happy to take some questions. If you have additional questions for me, this is my contact information. Carlisle Howard is our communications coordinator. She's the one that actually set up this contact for me, and she would be a great resource for information on our outreach and communications products. And then if you have any questions on the science or would like to talk to us more, please let me know.
Did you have one question that came in?
Mm-hmm.
It's, our ancestors used to settle around a watering hole. It seems our current development is still following the same principle. How do we integrate proper / strategic planning with the need for drinking water, which is a public health issue?
It does seem like that. I've actually often wondered that myself. People really want to be near water. It's calming. There must be something evolutionary about that. I think that it's going to have to be a balance. Obviously, we can't have urban areas developing around all of our freshwater resources, and we do want places for healthy recreation. We are going to need to set aside some land to conserve, which I think most of you know listening in on this call. So it's about finding a balance, and through tools like what we produce through CLI, my hope is that it reduces some of the uncertainty with regards to the future. So we aren't just using what we know about our past decisions and what we understand about the current landscape, but we also have a way to take into account in an objective way, informed by human behavior, what the future could look like, and where, given that, might we want to use our resources to best prioritize and efficiently capture those resources and protect them for us for the long term.
Great, thank you.